Okay, so the next test, you follow me. Okay, 5.3F, I think. So let's write it down. Test 5.3F. This will be under your exercise 5.3, question B, 9 and 10. We'll find this on textbook page 118, I think. So right likewise. Yes, 118. Let me read the question number 9 for us now. So we'll start with B9. Look into your question. If the sum of the first 7 terms of an AP is 49, and that of 17 terms is 289, find the sum of the first n terms. So here we are clearly given some data here, that is sum of first 7 terms will be S7 is given as 49, that is given in the question, then and sum of 17 terms, so sum of 17 terms means S17 is given as 289. So these two information are given. Okay, so find the sum of n terms. So we have to find sum of n terms. That is what we have to find. Let us start with what is given. Since sum of 7 terms is given as 49, so applying this formula S7 in corresponding with this here, Sn equal to n by 2 into 2a plus n minus 1 into d. So let us apply that. So n is here 7 by 2, n by 2 into 2a plus n, and our specific n is 7, so n minus 1 for this one, and into d. So let us write that once here. So having done that here into d, close it, is equal to 49. Then here that implies 7 by 2 into 2a plus 7 minus 1 is 6 into d is 6d is equal to 49. Then let us write this one as it is inside this bracket here, this one, 2a plus 6d equal to 49. And then if we shift this here, 7 by 2, here no sign means into, so 7 by 2 into, if it is shifted to right side, then the numerator 7 will go down and the denominator 2 will jump up here. So here 7 goes down, 2 which is down goes up, right? And 7 ones are 7 and 7 sevens are 49. And if you watch or observe carefully here, you can see 2 is the highest common factor of 2 and 6, so we can just remove it to make it easy. 2 into 2 is taken out, then inside will be a plus 2 3s are 6, so we put there 3, so 2 3s are 6, and here d, close the bracket, is equal to 7 2s are 14. So here 7 2s are 14 by 1 means 14 only. So here a plus 3d, why we remove this highest common factor is we can shift it to the right side to divide. Down here it will go 1s are 2, 2 7s are 14. So we're going to get here a equal to, just observe carefully, 7 by 1 means simply 7, and then this one shifted to right side becomes plus 3d becomes minus 3d. So let us keep this one as 1. Then again, or since, again means another data is here, sum of 17 terms is given as 289 in the textbook. Okay, so here following the same formula here, same thing, n by 2, so that will give you n is in this time is 17 by 2 into 2a plus n is 17 minus 1, n minus 1 into d is equal to 289. We are using this formula S17 here, Sn, n is now our specific case, n is 17, so 17 by 2 into 2a plus n minus 1, 17 minus 1 into d, applying this first formula. So here it gives you here, you cannot do this part, I think, 2a plus 17 minus 1, 16d is equal to 289. And if you shift this 17 by 2 to right side, like we did just a moment ago, numerators 17 up will come down, denominators 2 will go up. So I think 17 into 17 is 289 if I'm not wrong. 49, 4 in hand, 7 was 7, 8, 9, 10, 11. See here, you can see here for yourself. So we can see 17 into 17. So 17 ones are 17. 17 into 17, 289. And we can see here 2 is again highest common factor for 2 and 16. So you take out the 2, then inside the bracket will be only a plus 2. How much is 16? You find out that 2 8s are 16, so 2 has been taken out. And here 17 into 2 is 34. And 34 divided by 1 is 34 only. So a plus ad, just keep it like that, and 34. Why we took out this common factor 2 is we can shift it to the right side to go to denominator and cancel this. 2 ones are 2. 2 into 17, 34. Now observe this carefully here. So here that implies this a value is here found out in equation 1, a equal to 7 minus 3d. Can therefore replace this a. So 7 minus 3d replaces a plus here 8d is equal to 17 by 1 is 17, and we can write here since using, just remove this part, value in equation number 1. Then here next we get here 7, then minus 3d plus 8d means plus 8 minus 3. So subtraction, because plus minus means subtraction. 8 minus 3 is 5, and bigger one is plus, so here also plus. You can write those things on your graph. So minus 3d plus 5 plus 8d, in other words, is plus 5d, is equal to 17. So let us take the term containing d, which is 5d alone, and 17 on right side same. No sign in front, plus 7, go shift it to the right side. So minus 7. What we're doing is putting the term having d or containing d on alone on one side and shifting the rest to the other side. The purpose is we're trying to find out the value of d. So here 17 minus 7 is 10. So we're going to get here d equal to 10. You can go that side for spacing. So d equal to d equal to 10 divided by this 5 will come down. So 5 ones are 5, 5 twos are 10. So d value is 2 by 1 means 2. So to find out a here, we have to find Sn. We don't need this part, so we can just write it down. So putting this value that we found out here, d equal to 2 that we got just now in equation number 1, we will get, or we get, let's just write down equation 1 once. A equal to 7 minus 3d, that is the exact expression of equation 1, so we can write that once. So 7 minus 3 into d value, we are going to put here 2, d equal to 2. So 7 minus 3 2s are 6. 7 minus 1 plus 7 minus 6 plus 1, sorry. Now since we know a value 1 and d value 2, we can easily find out the sum of n terms, I think. So therefore, what the question is asking on, find the sum of n terms, Sn. And you can apply exactly that formula, Sn equal to n by 2 into 2a plus n minus 1 into d. This one, n by 2 into 2a plus n minus 1 into d, the exact thing we have put here. So it's just a matter of solving, I think, now. Gives you n value we don't know, so n by 2 into 2 into a, just now we got here plus 1, plus n we don't know, n minus 1 into d, and d is 2. As you can see here, d equal to 2, so we put that d as 2. Then here, that gives you n by 2 into 2 ones are 2. You can write that. Then here, you can multiply this plus into plus, plus, and then plus into plus inside, plus. So 2 into n is 2n. What I'm doing is multiplying this 2 to both of these to remove this bracket. Plus into plus. No sign here means plus, right? Plus into plus, plus. Plus into minus, minus. So 2 ones are 2, and this is still there. That way we can clearly see here now that here plus minus 2 and plus 2 becomes 0. So you're left with n by 2 into here 2n. Plus 2 minus 2, 0. So that way we can easily 2 ones are 2, 2 ones are 2. So you're left with n into n equal to n square. Right, so the value for sum of n terms is n square. Same as the textbook answer, yes. That's our answer. Now B10. Question B, number 10. Let me read it out for us. Show that A1, A2, etc. up to AN net term form an AP. So we have to show that this is an AP. Where AN is defined as below 1, AN equal to 3 plus 4n, 2, AN equal to 9 minus 5n. So let us start with 1. Here given to us is okay, given to us is AN value, and the first one there, number 1, is 3 plus 4n. That is the condition. Keep that in our mind. Now A1 will therefore be following this pattern for condition for number 1. Condition is AN is having this expression 3 plus 4n, so A1 following this logic or pattern can be written as 3 plus 4 into n. Here n is 1, so here we replace the n by 1. So 4 ones are 4, plus 3 is 4 plus 3 is 7. So A1 is going to be plus 7 when we apply this condition AN equal to 3 plus 4n for A1. Similarly for A2, 3 plus 4 into our specific value for n now is 2, so replace that n by 2. 4 2s are 8 plus 3, 11. Then likewise we go, I think up to A3 would be enough. A3, then 3 plus 4 into n value now this time is 3. 4 3s are 12 plus 3 is 15. So it goes like that, continues A4, A5, A6 like that. And let's go and find out here. Textbook, I think, is the same here, yes. So let's find out for A, n minus 1 following this condition will be 3 plus 4 into our n this time is n minus 1. So I'm going to replace the n by the n here, which is n minus 1. So that will give you equal to 3 plus 4 into n is 4n. Plus and the minus is minus. 4 ones are 4. So when we multiply the outside to the two terms inside, the bracket here will remove or get removed. Then minus 4 bigger plus 3 smaller absolute value, these two means subtraction. 4 minus 3 1 bigger 1 minus, so here also minus. So we're going to get here 4n and plus 3 minus 4 is minus 1. Minus 1 plus 4n. I'm writing this one first and this one second. Whether you write minus 1 plus 4n or 4n minus 1, is the same. I like to write the expression which is plus first, so I'm just writing like that. Okay, so and then likewise we're going to get here for an. So an we are already given 3 plus 4n, as you can see here. An equal to an a little bit down. Then here, let's do like this. Now, again, now, this a2 minus a1, let us do a2 minus a1 is going to be here 11 minus 7, 8, 9, 10, 11, so plus 4. So common difference is same or not, let us see. Then next is a3 minus a2. a3 minus a2 means 15 minus 11. Again 15 minus 11 is plus 4, same. Then let us do this here. an minus an minus 1. Common difference is if in a sequence of numbers, if at all there is a common difference, the common difference formula is higher term minus the next consecutive lower term, a2 minus a3 minus a2, or a2 minus a1, or an means minus the lower one, n minus 1, an minus 1. So here will be an is, as you can see, 3 plus 4n, that accounts for an, minus, so you put the minus. Then an minus 1 value here, an minus 1 value is 4n minus 1, so 4n minus 1, and we need to put this bracket because there's a minus here, this minus here. An minus 1 value, this one we have put, they'll give you equal to here, this one here, I can just write 3 plus 4n, then this minus, when we multiply to the 2 inside terms, bracket will get removed, so minus and the plus is minus 4n, and minus and the minus is plus, so plus 1. So minus 4n plus 4n is 0. That leaves you with plus 3, plus 1, which is plus 4. Plus 3 plus 1 is addition, plus 4. So it's the same again. So you can see that a2 minus a1 is 4, a3 minus a2, so 4. And likewise, a-nth term value minus a-nth minus n minus 1th term is also 4. So the common difference is same everywhere, means that's an AP. So since here, we can write here a k plus 1 minus ak. This is the general expression for common difference. a2 minus a1 or a3 minus a2, all those are represented by ak plus 1 minus ak generally. So since ak plus 1 minus ak value is same everywhere or every time, okay, because of this reason, therefore this sequence of number given a1, a2, etc. on the question, comma, an, okay, an, etc. Then an, if you want to go more also, all this form an AP. In other words, it's an AP. Question first saying determine, show that they are in AP. So we've shown that they are in AP because the value of the ak plus 1 minus ak, which is a2 minus a1 or a3 minus a2 or an minus 1 value are all 4 in each cases here. 4 everywhere 4. So it is an AP, and AP, the only condition for AP is they must have common difference, and they have a common difference here, 4. Common means same. So with a common difference value d equal to plus 4. Now we have to do something else. Also find the sum of the first 15 terms. Therefore, sum of the first 15 terms means S15. sum of the 16 term means S16. So following that S15 is, you can now put this one n by 2. Okay, n by 2. So the value is, yeah, so number of terms, so n is therefore 15, so 15 by 2, n by 2 into 2a, or a1, 2a, plus n is 15, so 15 minus 1, n minus 1 into d. Common difference is, okay, just write it once. That's the formula. So let's do slowly. 15 by 2. 2 into a means the first term, a or a1. So here a1 value 7. So you put there 7. 15 minus 1 is 14. So 14, the common difference is plus 4. Is there with a common difference 4. As you can see here, a2 minus a1 or a3 minus a2 are the formulas for common difference. So it's the same 4. So next here, 15 by 2 into 2 7s are 14 plus 4 4s are 16, 1 in hand, 4 1s are 4 plus 1 5. Let's go about doing this slowly. So we're going to get here, that'll be equal to 15 by 2 into 56 plus 50 plus 10, 60, 66, 67, 68, 69, 70. So it's 70. In other words, plus 56 and plus 14 will make addition. So 10 plus 6 plus 4, 10, 1 in hand. 1 remainder plus 1, 2 plus 5, 7. So the sign is going to be plus. So 2 1s are 2 and 2 3s are 6. 7 is there, so 1 remainder. That 1 remainder will go to the left of 0, right? Becomes 10, and then 2 5s are 10. So our answer would come out to be multiplying 35 into 15 will be the value of S15, sum of 15 terms. So let us do that and write the answer. 5 5s are 25, 2 in hand. 5 3s are 15 plus 2 remainder 17. 1 5s are 5 and 1 3s are 3. So 5, 12, 7 plus 5, 12, 1 remainder. 1 remainder added to 1, 2, 2 plus 3, 5. So you can write these things on your right. The sum of the first 15 terms will be 525. I hope it's the same as textbook answer. Yes. One more subheading, subheading 2, and we're going to complete this test part. Same pattern you're going to do for solving, same process. Okay, so here B10 subheading 2, here AN value is given as, look into your question, 9 minus 5n. So the condition for AN is 9 minus 5n. Therefore A1 following this logic will be AN is 9 minus 5n, means A1 will be 9 minus 5n, and here n is 1, so 5 1s are 5, plus 9 minus 5 is plus 4, plus 9 minus 5, subtraction, and bigger one plus. And A2 will be 9 minus, following this formula, 5 into our n value is now 2, so 5 2s are 10, which is minus 10, and here smaller one plus 9. So minus plus means subtraction, 10 minus 1, 9 1, and bigger sign minus, so this one minus 10 plus 9 is minus 1. And A3 value, 9 minus 5 into 3, because now n will be replaced by this 3. 5 3s are 15 minus 15, because minus is here. And plus 9 will be subtraction, 15 minus 9. 6, I think. Yes. Then bigger one minus, so here minus 6, etc. It goes on, and therefore AN minus 1 will be, following this formula, A3 is this one, so following this 9, 5 into our n is now n minus 1. So be careful with that. So here n minus 1, this n will be replaced by n minus 1. 9 minus 5 into n is our n here is this one, n minus 1. It gives you here equal to 9 minus 5n minus in the plus minus in the minus plus, then 5 ones are 5. When we'll multiply like that from outside to the 2 inside terms, then the bracket here removes. So that gives you 9. Okay, and we can settle this here. Plus 9 plus 5 means addition, 14 plus 14. So I write here 14, and here this 2 is plus 14 and this one minus 5n. So the value for an minus 1 is 14 minus n. And the one higher to this an value is already given. Exactly 9 minus 5n. Now, let us try to find if there is a common difference. We can find out by the formula. A2 minus A1 or A3 minus A2 or an minus 1, higher term minus the next lower consecutive term. So A2 is here minus 1 minus A1 is 4. See, A2 minus 1 minus A1 is plus 4. So both minus means we add 1 plus 4, 5. Both minus means minus. Minus 4, we know when both are minus, we add 4 plus 1, 5. And both are minus, the sign is minus. Then similarly, A3 minus A2. Be careful here, minus 6 is A3. Minus here, A2. A2 is again minus, so put bracket. Minus here, A2. Again, minus 1. So that will be minus 6, minus in the minus, plus 1. Which will be equal to minus 6 plus 1 is minus 5. So it seems to be the same. First A2 minus A1. If there is a common difference, there's a formula for common difference is minus 5. A3 minus A2 is also can be the common difference. If there is, it's also minus 5. Seems to be the same. So most probably this is also AP. So here, next one is continuing like that. And then let us go to the last two terms. An minus 1, because you see it's always A2 minus A1, higher minus lower. Higher is n, the next lower term will be n minus 1, right? 5, then A5 minus A4. So 5, n is 5, then 4 means 5 minus 1, 4 will be equal to here. Okay, let me rub out this thing so I can have space. An minus 1 minus an will be here. An minus 1 value here. 14 minus 5n. And minus an value here, 9 minus 5n. So if there's a minus, we need to put bracket 9 minus 5n. If we solve this, then 14 minus 5n. Minus into plus minus 9. Minus into minus plus 5n. So bracket gets removed. Plus 5n minus 5n, 0. So we're left with here no sign means plus 14, here minus 9. So plus minus means subtraction. 14 minus 9 is 5. And something has gone wrong here. 14 minus 5n. Let me check the book answer. Yes, an. A2 minus A1. Oh, number 2, sorry. Yes. An 14 minus 5n. An minus 1. An minus 1. 14 minus 5n. 14 minus 5n. Oh, we got it wrong here. This one, see. It should be. Please remove this one. The common difference is always higher minus lower, right? Let me see the textbook. Yes. A2 minus A1. So higher one is an minus an minus 1. See, A5. Then the next is common difference is A5 minus A4. Just like A2 minus A1, if there is a common difference, it's the formula for common difference. So an should come first. I made a mistake there. So here AN value here is 9 minus 5n, 9 minus 5n minus and minus 1 value here, this one minus 14 minus 5n, 14 minus, close the bracket. Then here we're going to get 9 minus 5n, minus and the plus is minus 14, and minus and the minus is plus 5n. So minus 5n plus 5n is 0. So we are left with the bigger absolute value, means the value without the sign. Value of a number, this considering or not considering the sign, is called absolute value. So absolute value 14 is greater than 9. So minus 14 having bigger absolute value up, and smaller, no sign in front, means plus 9. So minus plus is subtraction. 14 minus 9 is 5. Bigger value has absolute value as minus sign. So the answer here 5 will also have minus. So it's the same here. See, A2 minus A1 minus 5. A3 minus A2 also minus 5. Likewise, an minus 1 higher minus lower, next consecutive lower value is again minus 5. So it's the same every time. So since the supposed general formula for common difference we know is AK plus 1 minus AK is same every time, therefore A1 comma A2 comma continue etc AN comma continue etc is in AP very clearly, because the only condition for AP is they must have common difference, and the common difference is here minus 5 minus 5. Common difference means same values in minus 5 coming out same every time, and if it is AP, surely it has common difference. So with a common difference D value of minus 5, as we can see here, minus 5 common means same everywhere. So we have now got to find the value for Sn. So here each question has sum of 15 terms, so S15. Therefore sum of the first 15 terms in each case they said. So even in the second case, sum of 15 terms is n by 2. Following this formula, n is now 15, as you can see here, by 2a plus n 15 minus 1, n minus 1 into d. Close the bracket, and then here 15 by 2 into a. As we calculated a, I wrapped it out here. So a1 did like that, not it right, okay. 9 minus 5 into 1 is 5 into 1, 9 minus 5, and 9 minus 5 plus 4, so 4. You check your notebook, the a1 was 4. Now a1 or a is the first term, is the same, okay, plus 15 minus 1 is 14 into common difference. Here common difference value is minus 5, so close the bracket. So that gives you here 15 by 2 into 2 4s are 8 plus, with plus in the minus is minus 14 into 5, 5 4s are 20, 2 in and 5 1s are 5, 6 7, so minus 70. This 2 minus 70, 2 4s are 8. We can see here bigger absolute value is minus 70, smaller is plus 8, so plus minus means we subtract. So 10 minus 8, 2. 1 was taken from here to make 10, so only 6 left. Bigger one minus, so here also minus. You can write these things on your graph. So 15 by 2 into minus 62 plus 8 minus 70, in other words, is minus 62. Okay, minus 62. So you can cancel these 2 1s are 2, 2 3s are 6, and then 2 1s are 2. Then 31 into 15 is our answer. So plus and the minus is, you can do slowly. 2 1s are 2. 2 1s are 2. Okay. So here now, plus and the minus is minus 31 into 15. Then here, 5 1s are 5. 5 3s are 15. 1 1s are 1, 1 3s are 3. 5 6 4. So minus 465 is the value of the sum of first 15 terms. Yes, same as book answer, yes. Minus 465. That concludes the part 4, test 5.3F. Okay.